因为当前啊。Okay, now we are in week 12. Your lab report due today, 5 p.m. After 5 p.m., consider no submission. You get 0 marks. Okay, then assignment due 17 November, next Friday, 5 p.m. Then after your sem break or the power break, we'll have test 2 on Friday. Wednesday, we'll do revision. Then week 14, we'll do revision. Okay, now, last lecture, we stopped at this example 1. Example chapter 8. So basically, chapter 8 is about L equal to momentum mv. Okay, and for chapter 8, the focus part is at the center of gravity. Right. So L is a momentum. Capital L, we use capital L to represent momentum at central of gravity, center of mass. And then using moment concept. What is moment concept? You need to refer to force multiplied by distance perpendicular. You get moment. Right? F multiplied by d of mass. Okay, must be perpendicular to each other. So here in chapter 8, you use the concept of moment. You get moment of linear momentum. Okay, or we call it angular momentum. We use H equal to the same, but now we are not using force, we're using L or using momentum. So there's a distance multiplied by the momentum. So here, we just write I omega. Okay, so I omega, it depends. So this IO equal to IG plus MD square. So if the focus is on the center of mass or center of the object, then this one becomes G, right? MD will become 0. And where to find the G will refer to table. Okay, refer to table. Okay, so as you can see on example 1, another method is that you can use IC method. H equal to IC method. Okay. To use IC, you need to find the velocity and the omega. Okay. There will be one question come out from here in chapter 8 for your test 2. Test 2. So for test 2, you need to use principle of impulse and momentum to find the solution. Okay. So what is principle of linear impulse and momentum? Again, in previous chapter in particles, what's impulse? When you take your okay, so you have we know F equal to ma. This is in a translation motion. What I mean by translation is no orientation changes, right? So it can move in a straight line or it can move in the circular motion in translation. So F equal to ma. Again, in chapter 8, we focus right from mass. So acceleration, velocity, everything was at the center. So we label as a sub G to remind ourselves that we're focusing on center of mass. All right. Then we expand the definition of acceleration as we learned in chapter 1. So acceleration equal to dv dt. Okay. So you can move the dt into the front. It will be dt bracket mv. Okay, you can pull your dt outside and then put the m together with the v. And in this chapter or in earlier chapter, you know that combination of mv will become momentum, right? So when you get momentum, and this one is t dt, so you move the t dt to the left hand side, it becomes f dt, and this one is m dv, or m is constant, so we move the m again to the left hand side again. So left hand side you have dt, right hand side you have dv. You have d something, then you do integration. Then to do integration, you need the limit, upper limit, lower limit, or the boundaries condition. All right. So for example, time number 1, velocity and the central of gravity is number 1, value number 1. At time number 2, velocity as value number 2, and so on. So you modify or rearrange the equation on the top. Okay, you move the dt to the left, then you'll see dt one side, dv one side. M is constant because in rigid body there's no loss of mass. There's a change of velocity. So it will become the second row of the equation, right? You integrate f dt, mv minus mv. So from here, you know that f multiplied by time is the impulse. mv is momentum. This one become principle of impulse and momentum. Or when you see the question force you to use principle of impulse and momentum, then try to remember what is impulse decimation. Impulse is f multiplied by time. Momentum is mv. So it basically impulse is in one body. Then you rearrange this equation, either or the one that on the slide here, right? So either the middle one, this one, or the one, this one. So the one that you see, the third equation here, is what happening before the incident equal to after. So before mv plus impulse happen, or changes of impulse, will equal to the momentum after. You can write the middle one or the third one. Same, it depends on how you memorize. Some textbook like to use the third form. Some textbook like to use the central form. In our class, you are free to choose any form because they are same. Okay. Basically, this form also you've seen in the particles. Only the differences here is because you are looking at rigid body, we are focusing very heavily on central of mass or G point. Okay, these are different. Okay, so we introduced you this morning principle of impulse and momentum, and again, this will be in your test 2, question 2 question. It happened in after your Deepavali break. Okay, so once you have this one, you can incorporate your, you can imagine this is a strict component. The MV here, and this one is, MV here is moving in translation. MV is a straight line motion. So this one is moved in a straight line. Although here got one moment here, I omega is a moment. Right. So we move in a straight line. So this is an initial moment diagram plus the changes of impulse F multiplied by time. So here you see there's again, this is your initial moment diagram. This is the impulse diagram. This is the final momentum diagram. Okay. These are the diagram that we expect to see in your solution answer. So if you write this one, I will highly recommend you, after you write this one, you try to draw these 3 diagrams so that you know what's happening and what are the parameters that you should include in your calculation. Because here you cannot see most of the thing. If you draw these 3 diagrams, when you sum out the vector inside here, you won't miss. Right? For example, here, you include I omega and the velocity at the center of mass. Plus this one, impulse is impulse in or out. It can be in or out. This one have 3 forces. As long as you have forces, then it will create impulse. As long as it's impulse, then you create. So what mean by force? Force, it can be external force, it can be the capital W mg, right? Moment also can create force. Then equal to final momentum, I omega, and the mvg. So this is a bit different compared to the mass, compared to the particle chapter. Particle chapter, you only look at omega, capital W mg. You don't have inertial effect, Ig you don't have, right? Particles, you have m dt. This one. Okay, so that is the difference between rigid body and particles. So you have principle linear impulse or principle of impulse and momentum. Another one is principle of angular impulse and momentum. Okay, so the first one is for translation, right? Straight line or circular, that without changing of orientation. So if there's a omega happen, there's a rotation happen, then you need to include angular impulse and angular momentum inside. So what is angular momentum? Mg equal to I alpha. This one you learn in the, I think, chapter 6, right? So angular momentum will be mg equal to Ig alpha. How to find Ig? From table. Alpha is the acceleration, angular acceleration. Then recall what is the definition of alpha. Alpha equal to d omega or dt. Okay. Then the same. We don't like dt. We move dt to the left-hand side. So left-hand side, you have dt. Right-hand side, you have dw. You integrate both sides, you will see the same form, like what you see on the top. Okay. Okay. You'll see when you move, rearrange the equation, you will become integration form. So m dt, integrate time, equal to I omega number 2 or n location to I omega number 1. Yeah. So sometimes we don't really go and mention principle of impulse, angular impulse or angular, a complete sentence for this one is principle of angular impulse and angular momentum. A complete one, a very lengthy. And on the top is principle of linear impulse and linear momentum. But sometimes the question will just simplify it as force you to use principle of impulse and momentum. It means that if the object have a combination of general plane, means translation and rotation at the same time, then it means it will force you to combine this one and this one together. Okay. Again, this is just another derivation when this one is a center of mass. So if the question asks you to focus on another point other than the center of gravity or center of mass, let's say point O, then you need to change the I, become IO, IO equal to Ig plus MD square, or or you can use IC point if you want. Okay, so there are two forms. Either on the top is for you focus on center of gravity or center of mass, you use capital G, or if the question asks you other than the center of mass, then you need to use IO. Means IO equal to Ig plus MV square or MR square, as long as there's a distance. Okay. So these two refer as these two, or either one of these is referred to angular impulse because you involve omega already. All right. So this what you read it's very clear on the screen here. Okay. Now to summarize, what you need to use to solve for your test 2, question 2 question or final exam question, you need to use momentum plus impulse equal to momentum. So mv plus ftt equal to mv square. And I omega plus m dt and ig number omega 2. Okay, it depends on which form you like. Sometimes you can just focus on impulse equal to the change of momentum. Angular momentum equal to the change of your angular momentum equal to the angular impulse. Okay, sorry, this is angular impulse. M multiplied by time is impulse, right? I omega is angular momentum. Okay, so it's not as hard as you think, as long as you understand the basic definition for what is impulse, what is momentum, what is linear impulse, what is linear momentum, what is angular impulse, what is angular momentum. As long as you understand, you just follow the wording here and derive. Okay. Okay. Same, you have 3 diagrams to do. This is the like a previous one. So if you have a general plane, then you need to consider the omega effect, moment effect, omega effect. This is a general plane. Okay. Okay, what else? Okay. So this is a combination of two. It's a general plane. So you have linear translation plus rotation. So you'll see the effect of what I highlight on the screen, mv, I omega, and so on. Okay. So F and M, when you need to use this integration, when you have this integration, sometimes your force will have equation F equal to 3t plus 3, sometimes, for example, moment equal to 3t plus 4, then you use integration. All right. Or if it's a constant, force and moment is a constant, you just put constant value inside the equation here. Okay. Okay, so we have come to the end of the lecture or end of your week number 12. So we expect you already polish up your integration skill, your trigonometry skill. I hope I won't see careless mistakes for sine, cos, tangent, and also careless mistake for integration, where you confuse with differential equation. This is integration. Okay. So okay. Now, as you can see here, this is the same equation, but it's just a different, it is split into x and y direction for convenient in analysis because you are looking at vector. Force is vector, momentum is vector. So it's good that you split this arrow here into x and y. Then you solve for x first. Then you derive y equation. Because here it will give you one unknown. This one will give you one unknown. Two equation, two unknown you can solve, simultaneous equation. Then here we'll give you another one. With this, most of the time, the omega will be missing. So when omega missing, you are given V. Once you find the V from these two, you should be able to convert V into omega. V equal to omega R. The R is from the diagram. So you rewrite V equal to omega R. So you move your R to the left hand side. So omega equal to V divided by R. You find your omega. Okay, nothing complex here. So the rest you read. I'll show you the example. So if you have this rotation body, a drum or this with the mass, and you pull with the rope. So when you pull with the rope, this will rotate in a circular motion. And you're given a blue arrow with a moment 6 Newton meter and a force of pulling 50 Newton. Okay, so just be careful to look at the unit. Here is Newton. Sometimes the question gives you kilo, give you mega, sometimes giga-Newton. Okay, so get yourself familiar what is mega, what is giga, what is kilo, or sometimes micron Newton, right? It's applied to the cord what around. Determine angular velocity. Angular velocity is what? Omega or alpha? Huh? Angular velocity is what? Is omega or alpha? Omega. So already know already. This is when you come to the last chapter, you already know already. V equal to omega R. You die there also need to remember lah. What is alpha? Sorry. Okay. So it tell you to find the omega of this 2 seconds. If you're given time, you will fall under impulse chapter. When given time in the question, it will sure ask you about impulse. Because force multiplied by time give you impulse. Momentum multiplied by time is impulse. From start, after start from rest, so you have a starting velocity 0. Also, what is the force component of the reaction at the pin? You need to find the force at the pin here. Okay, so what you learn in statics, again, you are converting connection or connector, a pin will equal to Fx and Fy. This pin, if it's a round body on the surface, it will equal to force like that. Okay. Okay, so you start with the free body diagram. You draw free body diagram. If you're given point, transfer the point into the free body diagram, A. Right, and we know that from our PowerPoint slides, you know that you always break your equation into X and Y direction. So in your diagram, just to remind yourself where is positive direction, negative direction. Okay, although this one was rotating in the tangent and normal direction, the question do not ask you where is the velocity, tangent and normal direction things. So you need to be careful. So you have omega there. Omega in this case, I'll follow the motion of the body. So if I get positive value, the thing rotate in a clockwise direction. If I pull this one, logic, it will rotate in a clockwise direction. Okay. So coordinate system is important. You should know where is your positive and negative direction. So we go back, label A, radius, forces, mass. Okay. So again, as I mentioned earlier, as you go deeper and deeper, you will forget capital omega. Don't forget. This will be the careless mistakes when it come to chapter 8 question. You can do all the moment inertia, but you'll forget there is a weight component in the free body diagram. Okay. Then you put in the one that at the connecting point, which is the red arrow at the point A. Okay. I just assume the force is AX and AY. Of course, you can ask Dr. Ang, can I draw my arrow to the left and to bottom? The answer yes. But if you get negative value after you find, you need to explain what is the real direction for your AX and AY. If you draw in different direction. Okay. Then you put in external force, external momentum, 6 Newton per meter. 6 Newton meter. Okay. So this one you read. So you know that the moment of inertia, I equal to half mr square. This one is at the center point of the circular disc. You don't need to memorize this one. You will see in the table. As long as you read the correct one. Okay. You substitute the value. You have the mass and the radius. Right. You'll get one value there. Important is the unit. Important is the unit. Remember to put in your unit. Don't calculate, then give me one value. So for example, this one highlight with yellow. If in the marking sheet, this one 2 marks. If you give me 0.2, you only score 1 marks. I'll put there unit question marks. Okay. Now, for question for chapter 8, standard equation, you won't go wrong. Okay. MV before plus impulse equal to momentum after, by using principle of impulse and momentum. Okay, if you see the question mention principle of impulse and momentum, it can be linear impulse, it can be linear, it can be angular. I just need to highlight this one. So it can be linear impulse, linear momentum, it can be angular impulse and angular momentum. Okay. So you have two set of equation. One is mv plus ft equal to mv number 2 split into x and y. And just to remind yourself, draw an arrow where is your positive direction. And another one is the initial effect, because this is a rigid body. So you have I omega plus mt momentum impulse or angular impulse equal to I omega 2. Okay. So once you write the red color equation, it won't go wrong. It won't go wrong. So you just substitute the value, right? So for example, here you want to see, I want to find m given v at here. What is the v at x? What is the v a1x? What is the value? If you look at the diagram, what is v1x? y0. Huh? Y0. You understand what is v sub a 1x, right? The correct answer is 0, but why? You must understand the why. It's not rest. Huh? You can say it's starting from rest, but it's not so accurate. Huh? Does A point move or not? Does when you rotate this one, A move or not? Does it move up, move down? No. So this one, point A doesn't move. So 0. A2, you don't know. A2 also doesn't move like actually. It doesn't move to this one. What is different is a velocity here. This velocity at the point here. This one is moving. The rope is moving. The outside velocity is moving. Tangent direction. Eh? So if you focus on A doesn't move. You can convert V into omega R. Just to let you know lah. Okay. 0, 0, both sides. Not 0, 0 lah. Momentum at point A 0. Before and after also 0 because point A doesn't move. But there is an impulse there. Okay. So what is the impulse? As long as there's a force on the body, there will be impulse. So impulse is force multiplied by time. So you look at the free body diagram, in x direction is ax. So ax multiplied by time. So if you don't know the time, you just write bracket t, but this question give you 2 seconds. Substitute time equal to 2. But again, yeah. Okay, then you look for the second one. But second one, why have something else? So again, velocity at y direction 0, velocity at y direction after the motion is 0. Then you have impulse. Again, what is impulse? When they have force with the time, you get impulse. So what are the force in y direction? Omega, capital W, mg. Just highlight. I want to highlight omega. Don't go and write this one mg first. You will confuse yourself if you write mg in the beginning. Write this one as capital omega. You can write capital omega equal to mg, but don't substitute value first. If not, you are confused with what you write in your answer. Sometimes we purposely put there's a G point here, small g. So when I replace capital A with a G point, in your answer, you'll see a lot of, if you substitute earlier, capital omega, or capital W equal to mg, in your calculation, you'll see a loss of G, you're confused. You will come out with G square in your answer, then wrong already. Okay. So again, it's a good practice. Don't substitute mg first. Unless you come to the last steps, then you substitute inside. Okay, so second steps, you get the second one. And the third one, how to find IA. IA is at where? This centered. Refer to table. Okay. But again, IA have value omega 1. They start from rest. Then the answer is start from rest, then become 0. Okay. You cannot use this sentence starting from rest for V. This starting from rest is for omega, angular, because this one doesn't move, point A doesn't move at all. It's a pin. Okay. Then after it rotate, after the action, it will have I omega 2. Again, IA, I just straight away give 0.2 lah. You calculate lah, right? IA equal to half mr square, or defer to the table. Okay, I just put it here lah. Okay. So you solve 3 simultaneous equation. Yeah. So simultaneous equation again. Try to remember how to solve quadratic equation. X equal to b square plus minus square 4ac, sorry, 2a. I think you need to check this one. I think this one is the correct one, plus 4ac. I think it's correct. Okay. You need to remember. Yeah, how to find the square root for quadratic equation. Okay, because square, you have positive, you have two answer, positive, negative value. You need to decide whether which one is positive, which one is negative. This one you done before, right? Okay. So of course you can skip this one. You can write x1 equal what, x2 equal what. But still you need to decide which is the answer you need to use. Okay. You're dealing with vector. Vector have direction. The answer will tell you which one is the correct one. Okay, so this is how you find it, solving 3 simultaneous equation. Okay, look at example number question 3. Same. Now we add one more drum, one more mass below there. Example 2, without anything, give you a force. Now I replace the force with one mass. And give you the velocity now. Just now is force. Now the question in the example 3 change to velocity. Okay, same radius for the disc. Now the mass change to 6 kilogram. And there's a mass 6 kilogram and 20 kilogram for the disc, given you moment of inertia. Moment of inertia equal to so and so. This question is very moment of inertia. This is a tutorial question. In the test, you need to calculate what is your moment of inertia for A. Oh yeah. This is a tutorial question again. That's why you see very conveniently the value is given. But when it comes to test 2 or final exam, you need to calculate what is the moment inertia for a certain point. Okay. If the cylinder is initially moving downwards with certain speed, determine the speed in 3 seconds. And if you see time, again, very high chances you need to use the principle of impulse and momentum. Okay. So again, draw free body diagram, same with all the axes, positive direction, negative direction, where is omega, positive direction. Again, this omega direction, how you know? I will highly recommend to follow the body motion. For example, this is rotating clockwise, so I follow a logic way clockwise. Although we keep saying we are using right hand rules, but for conveniently, because we don't want to get negative value in our answer, we will follow the logic motion in the question. Okay. So you complete the free body diagram. There's a force pulling down. Again, free body diagram is refer to the target object. Don't refer to the wrong object. So there's a capital W again. Don't substitute mg first. Write capital W. You can write at the side capital W equal to mg, but don't substitute the value first. Then you write the connecting point at A. Okay, then you solve lah. Okay. Tangent is equal to the mass of B. Then the rest is substitution using the 3 equation or 2 equation. Okay. The rest is the same. Okay. So you have two objects here. You have two objects. So we are looking at point A. You're focusing on point A. So your equation will be in A. And if you're referring to cylinder, there's another equation come out. Okay. So this is how you solve lah. You solve by focusing on a certain object. You have two objects. Don't sum this one as part of the object. You're dealing with rigid body now. Rigid body, you need to see what is the body parts you have. In the earlier chapter, particles, you sum everything together. But rigid body, you need to see as a two individual component. So here, I label as disc and cylinder. Okay, so for this, you substitute lah. How to find IA? Refer to table. Because this at the center of the disc is G point at the center here. Okay, you don't know the omega. And how to find moment? Again, moment equal to force multiplied by perpendicular distance. This is the force. Perpendicular distance is the radius. So force, radius, and the time, 3 seconds, given in the question. And I omega. All right. Now, most of the time in assessment, you need to find the time. In tutorial question, you're given time, but in test or assessment or final exam, we need to know how to reverse the solution where time is missing. We ask you, at what time it will reach a certain speed at 2 meters per second. It released from rest. At what time the object B or the rope will travel at 2 meters per second after it released from rest. You reverse. This one is missing. If the question asks you time. Okay. Equation still the same. So for cylinder, because how cylinder move? Straight line. Straight line, then you use linear momentum, linear principle, linear moment, impulse, and momentum. This is linear. This is rotation. So this one is in the general plane. General plane, this one do not move. So translation component you cancel. Okay. This object doesn't move left, right, up, down. So you don't need to use this one. You don't need to use these two. Because it's fixed. Cannot move. Zero. But of course, in your solution, in your final or final exam or test 2, please write these two. It will have marks for this one. You just need to write this one will be equal 0. Okay, the purple color you need to write out. Example 3, I skip this step because you will still get 0. But in the test, please write the red color equation and the purple color equation. Please write them out. Okay. So the rest is substitution. Okay. Okay. So here you have the purple color 2 when you substitute. So here you have VB. Here's only VB and T. T, you know how to calculate. T equal to the B mg, right? So you only know what's your VB. Okay, basically this one you don't have anything you need to solve. You need to find the tension here, but basically balance everything. So you want to find the omega V equal to omega R, you just rearrange, you will get what is your omega. Once you find the omega for rigid body, you can solve most of the problems. Okay. Omega 1, omega 2, you have your VB. So you can find what's your VB lah. Okay. Or this is solution number 1. Solution number 1, I give you another solution. You use impulse and momentum diagram. This one is a bit slow. This is another method lah, solution. This one you read lah. So you draw the 3 diagram that I mentioned before, plus impulse, plus after. Okay, this one you slowly digest. What does this mean? You still write the same answer. Okay. This one. Method number 1. Okay. Your this one, your mass is 6 kilogram. 6 kilogram. Oh, this one is impulse. All right, impulse. So you take B, E. Okay. So this one you look at this one. Look at this one. So you have impulse. How many impulse in y direction? How many force? Tangent. Tension cable. You have omega. You have ay. You have this one create, this one create, this one create impulse, this one create impulse, this one create impulse. Okay. So this tension is here. This 5886 is combination of ay and omega. Sorry, capital W. Okay. Mm. Mm. This one is MA. This one moment. Moment. How to find moment? E multiplied by distance. F D. This is F multiplied by perpendicular distance. This M dt. This is the integration of M dt. Okay, I go deep a little bit. We're going to finish. Okay. So the last one is conservation of momentum. Now, when you see the word conservation, normally it will be the same as particles, where we're not interested to see what happened in the middle of the process. Okay, which means we don't consider what happened to the force, what happening in the force. We only see what in the big picture, the motion before and equal to motion after. So when you have a linear impulse, so sum of linear impulse is 0. This is for linear impulse. For translation, translation means without orientation change. It can be linear, it can be circular motion. But if you have a general plane with the rotation, then again, is a system angular momentum will equal to system angular after, which is the h, right? It's the h. Huh? Okay, so let's look at example number 4. Okay, so example number 4, you're given moment of inertia Ig. Again, this is a tutorial question. In a final exam or test 2, you need to find moment of inertia from a table. Okay, so in a question for a final exam, you'll see mass, and it'll give you a statement, find something. Assume wheel doesn't slip or remount. There's a slide mentioned about this one on the friction force, whether it's conservative or non-conservative. Go back to the PowerPoint slides. What does this statement mean? Determine the minimal velocity at the center of mass, Vg. It must have just roll over the obstruction at A. So this one rotate. There's obstacles here. You need to go up, just need to go up. The force, they need to determine the minimum velocity so that when you roll this one, it can go over the obstacles. This application is in robotics or in autonomous systems. You program so that the system use sensor, camera sensor. It will sense what is the height of the obstacles. Then it will, in the algorithm, it will use the equation that we learned today. It will calculate what is the velocity necessary from the initial location to the obstacles. Then it will trigger the voltage required for the motor, and it will turn the wheel to pass through the obstacles. This is in the robotic application. Although you are learning mechanical engineering or engineering dynamics, the application is very wide, especially your time. So your time is on the robotic, IoT, a lot of sensors. So don't see this one as a very, very core mechanicals. It can apply in lots of things. Okay. So okay, so you draw the impulse momentum diagram. Before you have I omega, you have mv. Okay, so when you draw diagram, remember to input mv and inertial effect plus impulse. Okay, plus impulse. There's an impulse there at point A. Again, impulse is as long as you have a force. Force, it can be external force, it can be spring force, it can be weight, it can be anything as long as it's force. Okay, you learn about spring, you learn about weight, all these. Okay, then there's a point A there. Right? Why this one point this way? Because you're in a circular body that are drawn on the whiteboard here. Your round body, as long as there's a contact point, you always contact at one point. And it's 90 degrees to the point. Okay, so you draw capital W time, you get impulse, force multiplied by, this is the force pointing in. Again, if you don't know the direction of the force, just imagine yourself, you are that object. When you hit A, what do you feel? You feel the thing pulling you or the one that's poking you. In this case, if you hit point A, something is poking your body. So pointing means the arrow pointing into the body with a certain angle. Right. Then you will equal to the momentum after. So momentum is velocity multiplied by the this one. So I just randomly, I guess where is my velocity. I know that when I hit these obstacles, my object will move up like that. I just think logically. So this is, you need to have a good logic. When you hit something, where does the velocity point to? In this case, you hit A, it will bounce up. You hit A, you just continue to rotate. So rotate, when you hit A, it will go up like that. Of course, it says, can I draw straight? Can, but if you draw the MV2 vector straight, you are not answering this. It must have just roll over the obstacles. If it's straight at V2, it's not yet roll over. It just hit the thing only. To have roll over, it must go up the object. When it go up, the velocity go pointing up. Okay, so these are the things that you need to be careful on the small instruction here. So because this is rotation, you have an omega factor and inertial factor. Okay, so practice more on this kind of example. As you practice more, it become a habit. You will know what to write in the tree diagram. Okay, first diagram is all the force convert to moment. The first diagram is on the velocity. Where is the velocity acting on the center of mass? Second one is the impulse. As long as there is a force, it can be spring force, it can be weight. What else? I think these two is the most popular one. Then the third diagram is the velocity and the inertial. You don't see inertial in the particles, because you're now in the rigid body. You'll see inertial effect. Okay. So this is just a reminder. By comparison, force at A is much greater than the weight. The force at A will be greater than the weight. Okay. So how you know A is greater than weight? Is simple logic. You want to roll over. These two must be balanced, right? To roll over, your weight and A must be balanced, right? If not, it cannot roll over. Right? You must be able to, the A force must equal at least. At least. So this is with the angle. So when you split angle, you need a higher force because it's sine or cos relationship. Right? So you split this one into y and x. So your y is sine. Okay, your y component must be bigger than not bigger lah. Your a sine theta equal to omega. You move your sine theta to the left. You find that the a value is more than w. That is the meaning mathematically. Okay. So the rest you read. Okay. And you substitute. So you use conservation of angular momentum. Again, what is angular momentum? When you see this one, conservation of angular momentum, write H1 equal to H2. Don't think twice. This is angular momentum plus angular momentum H. Straight away write H1 equal to H2. It depends on what point you do, but if you write H1 equal to H2, you still get 1 mark for the general equation. Right? Then you look at the question, where do you focus on? In this case, it's point A. So you write point A. What is H? H is I omega. How to find I? In this case, where is your A? Your A is not at center of mass. So you need to change your I into IO and write beside your answer, IO equal to IG plus MD square. So here, all right? So you change your angular momentum into this form, or you can straight away write this one. It's the same. It's the same. When you convert this one, it's the same. Because this one, what is V? V equal to omega R. V equal to omega R, you will get this form. You will get, here I extend the equation for you. R M V plus IG omega. So this one, your V equal to omega R. So R M omega R plus IG omega. So this one you get M omega R square plus IG omega. You pull this one, omega out. You get IG plus MR square omega, same as this one. Same as form. Excellent. Yeah. You can go to the long way like this, or straight away write H1 equal to H2, then write H equal what? H equal to I omega. And depends on what location you do. Now you are looking outside the central mass, so it becomes IO, not IG. IO is IG plus MD square. What is D? D is a distance you measured from the point that you're looking at to the central mass. Okay, in this case, you're looking at A to the central mass here. This is the R radius. Okay, so nothing complex. It's all the important equation I write on the whiteboard already. It's just repeating, and substitute or solve simultaneous equation. Okay, so this one is just to find omega. Okay, so omega, how to find? V equal to omega R. You're given velocity. So sometimes velocity is not known. So you just put your omega in terms of velocity. Then substitute back. Okay. So you try, here actually is try to solve mathematically the equation, right? So you know that it's conservation of angular momentum. You write H1, H2, write what is H definition, right? Once you write H definition, then you look at the diagram, you know that V equal to omega R. So you need to replace the omega with the V. You need to find VG. So if the question asks you VG, change all the omega into V term. Okay, change this one to V term. Then you are solving one parameter only, which is the velocity. This is a mathematical solution. It is nothing deal with the engineering dynamics. Okay, so you find your VG number 2 equal to VG number 1. Then after conservation, if still cannot find the answer, try to look for alternative equation, which is conservation of energy. You pull out energy. You can do side by side. If the question forces you to do conservation of angular momentum, sometimes you arrive at 2 parameters, you don't know how to go, look for conservation of energy. Pull out energy, because energy, you look at 2 different of energy, kinetic and potential. Okay, so you pull in. So this is the diagram. Before and after. Before hit A, then A roll over. So I highlight with the light blue. So the distance it moves up from the initial position G. The G point, when it moves to A, it moves up to this distance. This distance is 0.003. How you know 0.003? You need to refer back to the question. Question give you this distance. Why we need this distance? Again, we are looking at energy. Why we need look at energy? Because we have two unknown to solve. We stop at V1 and V2. We don't know the value. And no more equation to use. So we think of energy. Energy, you try to see velocity and potential height, mgh. So you try to think, draw before and after diagram. Draw before and after diagram. Okay. So to roll over obstacles, wheel must pass position A, where V1 or VG2 or VG1 has to be minimum. Okay. So it's necessary for the kinetic energy at position number 2 equal to potential energy at position number 3. So this is okay. Position number 3, it means this is the position number 3. Position number 1, start to roll from rest. This is number 2 position, number 3 position. Okay, these two just differentiate. So energy doesn't loss. So energy, two kind of energy, kinetic potential. Put in the equation, kinetic equal to half mv square. Kinetic potential equal to, this one you need to memorize. Potential for rotational bodies is Ig omega square. This one is for rigid body. It's no longer, and this one is mgh. This is mgh. There's no change of h here. You got Ig omega square plus 0 equal to 0, right? Kinetic after 3. After 3, you just want to roll over here, means no more moving. Velocity 0. And mgh, h is here. Okay. Because it's the question mentioned, there's a point, just roll over. Just want to go up on it. Okay. So because this ball is maximum velocity at here, at position number 2, when you roll up, there's the position where velocity equals 0. Then when it roll down, that is because of you're converting potential energy into kinetic energy. Okay. So the rest you solve for the unknown. Okay. Example 5 is your homework. It's the same thing. Okay, this one your homework. Go and read. The bullet, you shoot a bullet to this one. This one will swing. This one you read your homework. And again, when you see pin, please convert pin into forces. Don't forget, pin into forces. And again, I want to highlight, don't forget the mg or capital of W in chapter 8 question. Don't forget this one. Because when you come to chapter 8 question, you are so eager to solve using conservation, equation, principle of so and so. You have so many things you solve, then you forget what is it. Okay. 5, your homework. Split very fast. It's a lengthy things. Go home. Okay. So with this, I conclude chapter 8. So this is the last lecture for engineering dynamics.